Hello everyone, my name is Riley Dickens and I'm a consultant with Encryption Consulting. And today I'll be talking to you about the role of code signing in supply chain attacks. And I'll do that with an example of the most recent attack, the Kaseya VSA attack. So the reason this attack on Kaseya is considered a supply chain attack is because these supply chain attacks focus on companies like managed service providers or cloud service providers because they have a multitude of customers. So rather than attacking just one of those organizations at a time, they can attack a big organization that works with a ton of different clients and infect multitudes of clients at a time. So the reason with the Kaseya VSA attack that they used a supply chain attack is because there are 4 different vectors that they could attack from. So the first option is with the signing key, and this is just taking the signing key that is used to create a code signing certificate and using that to sign their code and pass it through. Now another option they have is of using an insider threat. And so a disgruntled employee may go and change their code before they send it through the CI/CD pipeline and then get their malware sent across to all the different customers of Kaseya. Now a third option available with a supply chain attack is the source code repository. And with this, someone could get into the source code repository and change any part of that code or change it to have malware, and that would then put that onto the customer's machines. Now the final option available for the different attack vectors with a supply chain attack is the build server. Now with the build server, the attackers can just pass their malware or their code with the malware through the build server and pass it on to the customers to infect them. Now let's talk a little bit more about the Kaseya attack. Now Kaseya is a software company that has different types of software like the Kaseya VSA software. And the way the Kaseya VSA software specifically works is that it installs agents on each of the endpoints of the computers of the users that are using the software. Now those endpoints have access to files and they can change files as well as automatically update their software when those software updates are pushed through. Now on Friday, July 2nd, 2021, Kaseya found that malware had been pushed through with an update automatically to all of their customers using the Kaseya VSA software. The servers for Kaseya VSA were shut down that very day and they had to inspect how that malware had gotten through into an update. What they found is that attackers managed to steal the private key of a legitimate company that works with Kaseya. That private key was then used to create a code signing certificate, which then allowed them to create the update with the malware inside and send it to be automatically updated on all the Kaseya VSA software. Now for the specifics of this malware attack, the way it works is that a file was first written into the working directory of the Kaseya VSA agent that had installed the update. Now once that had been written into the working directory, a PowerShell script was then used to turn off any antivirus tools that Windows may have. After those tools were turned off, the file was then turned into an executable and run on all the different agents. Now when running an executable from the agent, they need a code signing certificate attached to that executable. So what Kaseya found is that the attackers, like I previously mentioned, had stolen that private key, created the code signing certificate, and signed that malware. Now this supply chain attack was a huge issue because, like I mentioned with supply chain attacks, Kaseya is a managed service provider. So they had tons of clients, and that meant thousands of users got infected instead of hundreds. Now if they'd had proper code signing techniques in place, this attack may never have happened. Now with proper enterprise workflow management in place, Kaseya would have questioned this code signing process, and they would have gone back to the organization that had created the code signing certificate, allegedly, and asked them if they were actually trying to sign this code. Once they found out that wasn't the case, they could have stopped this attack before it even happened. If Kaseya had had strong and uniform key storage policies in place, or if they had required hardware security modules to be used to protect private keys, the key never would have been stolen in the first place either. Now, Encryption Consulting's product, CodeSign Secure 3.0, provides these points and more. We utilize FIPS 140-2 Level 3 hardware security modules to protect all code signing private keys. Additionally, our support of enterprise workflow management makes it easy to monitor and approve any code signing requests that come through. This protects the source code repository from having any code committed that has not been approved by another person first. We also use malware and virus scanning tools to ensure that no malware has been put in code before it is signed. This protects from any insider threats where a disgruntled employee might try and pass their malware through a code update. CodeSign Secure also utilizes multi-factor authentication, which means the build server cannot have any code pushed through to be built unless they have a valid MFA account. CodeSign Secure implements multi-factor authentication to protect data at the build server. It does this because code cannot be built unless it has first been signed in by someone with a valid MFA account. To learn more about CodeSign Secure, watch our CodeSign Secure video in the description below. And that's the end of our video for today. Thank you for watching, and please subscribe and like the video below. Thank you.